Hello, students. We are getting into the Math Connections 2-3, and 2-3 says you have 1, 5, and 8 through 13. So 1 is a justify your answer, and I think some of these, the odd ones, are in the back of the book. So um, not the best explanations. They do something very quick because they try to save on how many pages they have. But if A is an element of the union, is it true that it's in the intersection? Well, again, when they say justify your answer, maybe you find a counter example. Can you find two sets, an A and a B, where A is in the union? That means it's in at least one of them, but it's not in both of them. That would be what they're looking for. Okay. Same for the next one. If the union of two sets is equal, so A union B is equal to A union C, does that mean B and C have to be equal? And so start thinking a little bit and saying, hey, is it possible for these two to be equal, but those not to be equal? And if that's the case, go build B and C and then try to make a set A where the unions actually do match up. Okay. Right? So not too bad. But if you were thinking of saying, hey, I want two sets that are not equal, pick two sets that are not equal and say, ha ha ha, B does not equal C. Well, now you need a set A so that the union of A with B is the same as the union of A with C. So that means whatever you're thinking of has to be in at least one of the sets. Since a 7 and a 9 are not in C, they better be in A. And since 1 and 5 are not in C, they better, since they're in B, they better also be in A. So now if you take A union B, you're kind of, in a sense, almost duplicating these numbers, but they can't be duplicated in a set. They either exist or not. So A union B is A, and A union C is also A. However, B and C are not the same. Is this true? I would say false, and my justification would be right over here. All I need is a counter example. Okay. So let's see here. That was 1, 5, 220 students, 110 taking algebra, 90 taking biology, 20 took neither. Okay. Is it possible? So if you have 20 taking neither, that means there's 200 students left. Is it possible that of those 200 students, 110 were taking algebra and 90 were taking biology? Is that possible? Maybe you could draw a little picture to represent that. Then I've got the connecting to the class. So again, we've got, this is where you're dealing with students, right? So good student question. If I have two sets, can't I just shove them together? Wouldn't I have BC written twice? Go back. What's the definition of a set? Can I have an element written twice in a set? Think about what it means to be well defined. Question 9, a student's trying to find all the one-to-one correspondences. Well, we know how to do that. And they took the Cartesian product of the sets and claimed the answer is correct because it's all the possible pairings. So take a look, make an example perhaps to show the student, oh, okay, I see what you're doing, right? And then say to the student, well, let's see here, what's correct about it? Well, this is all of the possible pairings, but is that set a one-to-one correspondence? Like if a Cartesian product had 3 in the first set, 4 in the second, you're going to end up with 12 elements, 3 times 4. But does that mean those 12 pieces are one-to-one correspondences? Because that doesn't seem to make sense either. So maybe that could help you with something like that. Student says adding two sets. Tough call. We have a set difference, but we don't have a set addition. I mean, what would that even look like? If we're trying to put all the elements together, then that would just be the union, right? For putting those together. So I'm not sure. Now it's a good one to kind of say, hey, what do you mean by A plus B? Since we haven't talked about that. Question 11 is a good one. Goes back to chapter 1, right? You found 10 examples. That must mean they're always the same. Not always. Not always. You might be able to find some that it does work for 10, but it doesn't work for every one of them. Or it might work for 10 and it might also work for all of them. But the reason that it works for all of them is not because you had a certain number of examples. You need to have justification. Okay. 12 is a student who's struggling with the word or, looks like. Belonging to set A or set B. He wrote the union down to be A, B, C, F, G and ignored the D and the E that was in both of the sets. So what is confusing Hugo? And now we've got Seth. Seth decides to use D and C to represent dogs and cats in the universe of animals. I don't know. What do you think could go wrong with that type of picture? And where's the issue that might arise? Right? Hint, we kind of did this in class because I asked you to create what labels could you put on something that would make this not work. The intersection be empty. All right. I think that about takes care of it for 2-3. So I'll jump into chapter 3. Hopefully you're doing all right, and I'll see you soon. Off you go.